Okay, let's begin. Welcome everyone to the Programming Seminar Series Day 2, Managing Data Mining with R. So yesterday we had our first seminar of this series. And if you have attended that, I really appreciate it. And I think you, I assume you really liked it as well. Before we begin, there are a few things I want to tell you. So one thing, you can use the chat feature to ask the questions. But since this is a 1 hour seminar, I suggest you, if you have a lengthy question about the content, to keep it till the end, so you can ask the question at the end of the seminar. You can unmute yourself and ask the questions, or you can raise your hand, then I can unmute you, then you can ask the question. For those who attended yesterday's seminar, I have sent the slides and the recording, and all the recording of the seminar series will be available on next Monday in our website. And if you want to have the access to the previous events, you can go to our website and have the access to that. And if you have any feedback or suggestions, you can forward me that to my email. Okay, today the seminar will be conducted by Sneha Nimmagadda. So I'm going to give her to lead the seminar. Sneha, you are muted.
Sorry. Yeah. So I am a data science graduate student, and I have been taking data mining and take different courses in MTU, and I'll be telling you what data mining is about and the introduction and everything, and how machine learning will be also a part. I mean, how does data mining affect machine learning? Because I'm pretty sure you must have seen Dr. Timothy's presentation about machine learning and how the different models can be tuned, and how we can actually get some knowledge out of the data which we have. So, all right, so I am sharing my screen. So what actually is data mining? This is a process of getting insightful matter from the data we have and understanding what trends are in the data. So this includes getting what patterns do we have, and how getting some histogram out of it, and seeing if we actually have some knowledge out of it, get some data and improve it for machine learning models and predictive models. So the next thing is, why do we actually use data mining? So this can help us in changing the raw data into effective solutions. So let's say if if I'm going to a website and I have AWS, and how are Amazon people recommending me stuff? So what they usually do is they take the data and they see what are the frequent items being bought by different people and different customers, and do they have anything common in them. So they'll take all the common items and they will actually give me, okay, let's say if I have 10 items which are taken by the 10 different customers, I can probably suggest an item which the 11th customer is missing. So if I actually buy a watch and a shirt, and there are 10 other customers who have also bought jeans with it, so Amazon will show, okay, so 10 people have bought this, the 11th person, let's suggest probably recommending genes to the 11th person. So this is how that works, by understanding if there are any trends in the data and getting them for changing any, I mean, selling you more products or recommending you stuff. That's how even YouTube recommendations work. So this basically increases marketing strategies to change their product development, and do they have to really manufacture more items, and what are the most sold products and what are the least sold products. So when we are actually considering data mining, it's always about what, depending on the previous knowledge we already have. So I am not going to predict different features and if I don't have previous data. So I cannot predict something or forecast something if I don't really have some, I mean, previous data, which will tell me probably this is what going to happen. And so this breaks down the data into multiple ways to identify patterns. And so I'll say, if there's a bulk of data, it could be images, it could be any sort of tables, or like it basically can be a video, or you can get data from anywhere, and what depending, irrespective of what sort of data it is, you can break down the data into how many frequent items are there, how many, what is my understanding, what are the plots that I could get from out of it. So all these data will actually help us in understanding if there's a pattern or underlying pattern which will help the businesses to change their product or make the efficiency for future predictions. So where does data mining actually stand in data science? So from all the process of the data science, we have machine learning in the end, where you actually have to do a lot of pre-processing methods and data cleaning methods and everything to reach to the machine learning to actually predict something and get the models. So where is data mining? Data mining is just before the machine learning, I would say. So this has, if you can see, so this is called KDD process, and this is the data which will be collected from different databases. And so the 5 processors are data collection, and then pre-processing, and then transformation, data mining, and then this interpretation of results actually consists of machine learning. So what do I know about, like how do you actually determine what's best for your, prediction? So we have, like I think you must have seen yesterday that you actually have different machine learning models which will automatically give you the best results of the best model, and the accuracy will be the highest for it, and all the predictions are really great, from how many are correct, how many are wrong, and what can be improved out of the predictions. So when we actually collect the data from the data sources, and then it goes to the pre-processing, which includes different tools where we can use it by, and we can change the data using Python, R, or Hadoop, or different languages. And so that is where pre-processing is done, and data mining is to sort the data first into different target groups. And then if I actually have different sets of patterns and everything, I could be able to sort them and group them, and then send the sorted data into the machine learning models. So it's not just like, okay, I'll just send all the data, whatever I have, without the pre-processing into the machine learning model to give me some prediction. It will give you a really bad prediction, or the accuracy or the effectiveness of the model will be extremely low. So what we do is we follow all these processes before even reaching. And so data mining is just before we actually put in the data into the machine learning models. So how do we actually collect the data? Let's say if I have a Amazon ETL database, and then I will be able to collect all the resources or all the pictures out of it, and then I want to sort them. So if I have 10 pictures of 2 jeans or two shirts and everything, I do not know what I'm trying to sort them into. So if I really have to say menswear, women's wear, so I am supposed to go to the exact, so my model should be able to know what it is sorting into. So if I just click on menswear, it should show me all the, like all the tops or pants or everything and jeans and everything into one section. And then this should also show if I'm only looking for the pants section. So this sorting will be depending on what the model is and how this sorting could be done. And we do not want the data to be missed in different places. Like if I am looking only for women's wear, I do not want some kids wear into that section. So this is called, this is where data mining mostly takes place, in sorting or grouping them, even if we do not know what we are trying to label them into. So the kids section could actually have toys, or kids section do not have toys. I mean, they don't need to. So we just give the data, and we're trying to see, okay, now depending on the similarities or the dissimilarities, sort them into different groups. So this is where the collection or the sorting happens, where we have the ETL structure, or CRM is client resource management, and billing, supply chain. And then all of them actually go to the data warehouse. And from the data warehouse, we're seeing what are the frequent items and what are the patterns underlying. And then business intelligence will give you all the more, I mean, products which need improvisation. So these data warehouses are collected from central repositories called multiple, I mean, there are different sources from the databases. And the process we usually use is ETL. And this is where the first step begins. And the next thing. So the tools and languages that we use for database are SQL, NoSQL, and MySQL. And these are basically depending on if the data is sorted is in tables or not. So if we have unstructured data, we'll be using NoSQL. And if we have structured data, we will be using MySQL. So what are the tools available for managing the database? So we have different tools such as Oracle, Microsoft DB, PostgreSQL, and Teradata, Microsoft Azure. So all these will help us actually in determining how do we actually get the database, what things need to be changed, and what sort of data do I want to obtain that should be processed into different models. So we use SQL for that. So this is one example where I want to say, how does Amazon really works as a database structure? So when we have this cloud, this cloud-based management RDMS will have all these structured tables where SQL servers can be there, and all the cloud data will be gathered into one section. And then from different sources, it will be taken from SQL. Okay, do I want from this data source? I'll use MySQL to get all the tables and structured data. And if I really want all the pictures, I'll be using NoSQL, where I want to sort, I want to take or collect all the data using where basically unstructured data is there. I can take them and push it into a CSV or any other data file, which will be able to sort them. So this basically this is showing what language it's using. So MySQL and for relational databases, and NoSQL if there's no not unstructured data. So when we actually, so I can show you. So yeah, here when we have the data, it'll be really, I mean, unstructured, and it does not have really a good, it's not clean, and it might be having a lot of missing values, and this might not help us in predicting any of the results. And what we try to do is this big data tools will actually help us in clearing or sorting the data, which is higher number. Let's say if we give 1 TB of data to Python, it will not be able to run. So we are supposed to get Hadoop into the picture and connect Python or R to Hadoop, and then run them using different libraries where the computational time will be low, and the tool also will be able to actually process what the data is and what we're trying to do. So if we actually want a histogram of 1 TB data, it's not going to give us, Python cannot give us a histogram of 1 TB data. So this connecting to different data sources will be able to, they'll basically help us in processing the whole, big data. So these are extremely large and hard to handle, and that's an unstructured data. They basically need high capacity processing systems and often difficult to parse and process. So these are the 5 V's of big data, and they're called they have huge amount of data, variety of data. So including the text base, and there'll be different numbers, and then there'll be pictures. So all the data is not sorted. So if you were trying to get Python to learn a model and if you're trying to train a model, it cannot take a video as a data and then a text file as a data. So it will not be able to process both of them together. So this big data, which we get from different sources, have variety. And so this has even inconsistencies, and we need the data to be processed as, we need high computational processors, because we will not be able to do it without high computational, because every time you want to actually run a model, or let's say if you're training a model with SVM or any other, KNN. So if I give it some 5,000 data samples, it might just get stuck, and it could probably run for 1,000. It might not run for 5,000. So this is where our problem begins, where computational capacity needs to be high. And yeah, so big data is basically hard to process. And so the tools which we use for big data are Hadoop, HDFS, and then as you can see, there are different, Amazon AWS has a lot of services for big data, and then Google Cloud Platform has services, and then Microsoft Azure. So other than that, the main ones which actually will be able to process big data are Hadoop and Cassandra. So they're really good tools where we actually have whatever the data is, Hadoop will actually have multiple layers and parallel computation to reduce our time and to actually process all the data in parallel ways, so that it's not just like one function running it, they'll have multiple segments of it running. So the computational time reduces a lot with parallel computation. And then coming to the data processing, data pre-processing. So when we obtain the data or the big data from the sources, we need to actually process them, clean them, and transform, see that they're in a good state. So this pre-processing step is actually after the target collection. And so this is one of the most important steps, because if we do not pre-process the data, the models or the predictions are going to be really bad and the accuracy will be really low. So this pre-processing will be done before the data mining or any sort of statistical analysis that we're trying to do. So before any sort of analysis, we have to finish the data pre-processing step. So pre-processing involves various transformations, and these transformations are mostly like, we can use box cogs, normalization. So if I have people who are, if I have a lot of skewed data, skewed meaning, basically it's not like a bell curve. The data will not be having like a bell curve. It will be either to the left or to the right. So that data is called skewed data, and we need to process them or transform them using log transformation or center and scaling or different box cogs methods. And so we can do the pre-processing methods by aggregation, aggregation. Then we can sample the data, and if I have like 1,000 observations, but I just want to find the data analysis for the 100 observations, I'll sample the data into 100 observations, and then I'll sample the data into 10 different hundreds, and then I'll take them into consideration for my models. So dimensionality reduction is when if there are multiple predictors, and the predictors have a lot of variations in them, and I mean they probably might not be useful in our prediction. So what we do is we'll dimensionally reduce the data into, let's say, I just want these number of predictors, so I do not want the rest. If I have 1,000 predictors, probably 900 of them are not useful for my data analysis. So I'll remove all of them and then just use the 100 predictors for my data analysis. So removal of missing values, we are supposed to check if there's enough data for us to actually do any sort of data mining. And if we do not have enough data in the predictors, that will not be useful. Either we'll have to remove the predictor, or we'll have to impute new numbers, new variables, where we obtain them after prediction. So that's more like if I have 10 observations missing out of 100, so I'll use the other 90 observations to predict these 10 observations and place them into my data. So that's called imputation. And to continue the process for all the models. So the data mining for machine learning is basically, it has item set mining, graph mining, clustering, classification. So we have different classification is classification, regression, and everything is used mostly for the supervised data. So where we know what we're trying to find. So we know what label we're trying to find. So if I am trying to predict how many sales I want, so that number of sales becomes a supervised supervised learning, and we do know what we're trying to look at. So that if we actually know the label what we're trying to predict or look at, that's called supervised. And if we just give the data, unstructured data to the model, so that's unsupervised, and that's mostly it has clustering. So this item set mining, graph mining is mostly for like to determine what data we have, to find what patterns we have. So this group data can be used for accurate predictions and effective machine learning models. So item set mining is basically like if you have a web page with 100 words. So what are the words which are repeating multiple times? So let's say I want to have a threshold of the words which are repeating more than 50. So what I do is, let's put a histogram of the words, or the summary of words where how many number of words are repeating. So this is basically item set mining, where we're trying to find, okay, if from the summary, what can I find? I mean, is there any frequent values which are repeating, or are there any different mean or median that I can find? So this is basic patterns of the data, and so frequently occurring elements in the data can be found from item set mining. So, and this can also give the probabilities and percentages, saying, okay, if this is the data, probably in the next page, I might have another, I mean, probability of these words repeating. So item set mining, if this is just an example where we're trying to see how item set mining can be done. So let's say if there are different customers, where we have 3 customers who are buying milk, bread, and cereal, and milk, bread, sugar, eggs, and then we actually are trying to find people, we are trying to sort them, saying, okay, if people have bought sugar, they might probably also buy eggs. So if probably, if they're buying milk, they probably are also going to buy bread. So that is how recommendations also work. Let's say if you're trying to buy a bread from, if you're trying to buy bread from the market, and then they actually place something that's, let's say garlic butter or whatever, that is beside the breads always. So how are they placing them? They actually go back and see the item set mining, saying what customers are buying. If 10 customers are buying a certain thing, the 11th customer also probably will buy this. So we'll just place this with near to the bread section. So that's how the item set mining works. And then graph pattern mining is more like visualization of data mining. So where we have the visualizing patterns or the trends that we actually put on the graphs to see how the trends are going and what we can determine from them. So there are different graph pattern mining, like decision tree graphs, summary graphs. Decision trees are more like conditional based graphs, where if this is yes, so give me the possible probability of, I mean, out of 50, how many could be female, how many could be male. So it'll just give us the probability, saying probably there's 50% chance of, I mean, all the people having, all the people being male, or probably 50% chance of all the people being female. So graph pattern mining will just, decision tree will give us the probabilities of yes or no conditions. So then moving on to the summary graphs, these are the basic graphs which you already know, that like we have bar charts, histograms, box plots, and we have not all the data which has skewness, and if the data is normalized or not, so we can just find them all with the summary graphs. So these basically help in identifying if you're supposed to transform the data or not transform the data. So I mean, if I just have people, if there are 50 people in a class and 49 of them are between 20 to 25 age, but there's one person who's over 30. So this will just give us a description of what the spread could be like. And these visualizations basically help us in transforming the data into center and scale the data, or orthogonally transform the data with log or different transformations like boxcox. So this frequent pattern data can be seen like from the COVID graph, where we actually have a trend saying, okay, what is the trend of COVID increasing in different countries? So probably we see that we do see this a constant pattern in this, that it's initially increasing a lot and then it's getting stable. So the cases are, if it's initially the cases are increasing, so we see there's probably there's this country which does not have initial growth, but it has increased later. So most of the visual frequent patterns show that initially it is growing and then it is getting saturated. And then decision tree graphs. Going to this, how we have spoken about probabilities. So these are the predictors and this is our target variable. So we're trying to see if they play golf, yes or no. So depending on what the conditions are. So if the conditions are basically sunny and rainy and overcast, depending on these conditions, we are going to see how much probability. Let's say the probability of these three is 1/3, and then these three could be 1/6, and so the probability of yes or no could be 1/12. So that is how we divide, saying, okay, if this is the condition, what could be the probability? And we're trying to basically divide the predictors to find the target variable, and with this probability we can give it to the model saying, okay, so here's the probability of playing golf, I mean, a person playing golf or not. So decision tree will basically give us what are the probable outcomes from the data which we already have. And then summary graphs are the basic graphs, like this is a bar plot and a pie chart. So they're trying to give us the number of hours and the number of students are spent playing video games on weekends. So we see that the number of students increasing and the number of hours increasing. So these are the basic charts which show us what the trend is like. So here we just see that there's a linear, linearly they're actually increasing. And then pie charts, we do not really have here a proper structure where we can determine anything out of it, but definitely I think if there was histogram of pie chart, we can see if the data is normal or not normal. So going to the clustering. Clustering is basically a unsupervised learning, and these will actually have data that can be grouped into different categories. And so what we're trying to see is if we give a random data to a cluster, I mean, a model, and it is supposed to determine, are there any clusters? So I'll say, give the function of k-means and give me if there are enough clusters in it. I mean, what are the clusters that the model can find? So here there's an example of age increasing with respect to what their expenditure is. So the cluster is basically, let's say if I have, if I give data to the clustering algorithm, what can it actually find from the data? So this the algorithm probably might say younger people with lower budget are one cluster, and then older people with lower budget are another cluster, and middle-aged people with higher budget are considered into another cluster. So we can give different to a clustering algorithm, we can give the data and it can actually find probably these are the ones which we can find out. And then, so what could, I mean, there are different algorithms, but these are by using different functions, we have these clustering algorithms where this using distance as a function, we have hierarchical, and using density function, we have DBSCAN, and using centroid functions, we have k-mean subspace functions as by clustering, neural functions as we have, we can actually use neural networks into either in supervised learning or unsupervised learning. So if we are actually giving the data to the neural networks saying, okay, this can probably cluster in, the neural networks can cluster them into a proper category, then it's called unsupervised neural networks. And coming to the k-means clustering. So what we do in k-means is we try to give it a number of, okay, let's say I have 10 observations of data and I want to cluster them depending on, I want 2 groups of similarity structures. So let's say if this is the data, initial data, we can just assign 2 random centroids to it. And then what it'll do is it'll actually take the distance between them, and it'll find the centroid of the after first round. So let's say after initial seeding, the centroid has been changed and the new mean is this, and the new mean for the other cluster is this. So we again do another iteration where it says, okay, for all these distances or these points, what is my new mean? So this is the new mean. And another iteration for all these points, what is the new mean? So we keep iterating the points or the centroids till they're actually stable. So probably if we find another centroid to this, and this might not change for another 5 iterations. So that's when we actually stop saying, okay, this is where we're supposed to stop the k-means clustering, and the clusters are divided depending on the centroid, this centroid. And so basically it randomly we can give or assign a centroid, and then it will uniformly divide them, and we'll keep updating the iterations. So each iteration consists of 2 steps, that is cluster assignment and centroid update. So let's say I have some data point with data having sort of numbers, and I want to divide them into 2 clusters. So the initial mean, which I'll give it as 2, we can assign them as whatever we want. So, and then the other mean, I'll be just giving it as 4. So when we take the distance between them, we'll consider, okay, from the distance what we got, and checking the mean, we initially we'll just sort them into 2, 3 as cluster 1, and C2 having minimum distance with the mean, that is 4. So now after we divide these, we'll get a new mean, that is 2 plus 3 divided by 2, that is 2.5, and the new mean is 16. So now using these 2, we can go back and find the distance between 2.5 and 2 and 3 and 2.5. So similarly, if we keep doing that, we finally get the clusters as C1, which have 2, 3, 4 with the mean of 2.5, and C2 with all the higher range numbers with the mean of 16. So as you can see here, if we randomly give these 2 points and then we try to sort them saying, okay, just give me a cluster with, keep updating my class centroid and then give me 2 different clusters. So all the iteration or the k-means algorithm does is it'll keep changing the points and keep finding the new means so that the final clusters will be just 2, and I mean, they will not change anymore. And then, so moving to hierarchical clustering. So what this basically does is it'll just find the distance between 2 clusters and which are the closest together and combine them into one cluster. So it'll keep combining them. And let's say these 2 have the minimum distance. So this is one cluster. And then the cluster's mean and this point probably have the minimum distance. So now these are the clusters. And so the clusters keep combining until the whole data set will be covered into one proper cluster. So the dendrogram for this would be like, okay, let's say A and B have minimum distance, and then E and F have minimum distance. These 2 have minimum distance with the D, and the mean of D, E, F will have a minimum distance with the C. So that's how it works. And mostly hierarchical clustering is if we change that into dendrograms. So these are dendrograms where we can see that they all combine into one proper cluster. Then DBSCAN is basically what DBSCAN does is, let's say if a point or the data point does not have more neighbors, or if it does not have any noise, it will be considered into a cluster. And then how do we consider the noise points? We consider the noise points if we do not have any neighboring data point within that its radius. So that's let's say all these core points do have one neighbor or more than one neighbor, and border points just have one neighbor, and the noise does not have any neighbors. So we remove that. We consider that a point which does not have any neighbor as noise. So overview of this is we basically use the data mining as to find patterns, and then so after we group them, after we group the data, so we give that into machine learning. So these are the proper machine learning algorithms which are which can be used, saying if it's if we know the label, that's supervised learning, and if we do not know the label, that's unsupervised learning. And these are the clusters which we can use. And then if it's numerical in supervised learning, we use regression. And then if it's categorical, what we're trying to find is probably a yes or no variable, then we use classification. So we can go back to the case study and run the program in R, and we can see what R is doing and how we can actually do the data mining using clustering techniques. So, all right. Can everybody open? I mean, I am not sure if, all right, I'll just get back. I want to make sure if everyone can see the R file.
Sneha, we can see your PowerPoint screen. We can't see.
Okay. Okay, now we'll see the R file, is it? Sure, just a second. Okay, now you can see.
Yeah, now we can.
All right. Okay. So these initially, what we try to do here is install the packages which we have like. I'm just installing all the packages that we'll be needing for doing the data and our clustering methods. So ggalley is for basically giving the graphs, and NB classes for getting k-means clustering and everything. So I have actually installed this package, but what we can do is if I just remove the comment here, and you guys can install all the packages by removing all these comments. But since I've already installed these packages, I can just run it. And so after installing, we're actually supposed to call the libraries so that it'll actually know if you're running it or not. So installing will just not by default run the library. So here we're trying to read the customer segment data. So what the data is doing is, so it's actually giving us, we can see that there's no gender given in this data. So we do not really know that, okay, this gender basically has a lot of missing values. And the age, we're trying to segment, the basic aim of this is trying to segment if younger people with some annual income, how much would they be spending? So we have different ages here and annual income, and this is for 15K, and different people having different annual income here. So spending score is basically how much are they spending for, what, depending on their age, how much are they spending and what is their score with respect to their annual income. So this read.csv is basically giving us, we're trying to take the data into the, considering R, and we also saw that the customer ID, okay, we do not have the customer ID here. So we are just giving the customer ID, we're giving a predictor there saying the customer ID, take it as null. And then what we're trying to do here is we can try to look at the histogram of the mall data is basically our data set, and the syntax is if we just call any sort of data set, whatever we give here, and then with respect to, if we do a $sign, we get different predictors. So what do we want to see? Let's say I want to see the spending score of different people, and for this I can put it in the histogram function saying histogram of the spending score. So we can actually find that most frequently occurring is between 40 to 50. So the spending score of 50 is probably the highest, 40 to 50 is probably the highest. And then we can see histogram of age saying most people are between 30 to, I'm not sure, 30 to 35, yeah. So this will give us what the histogram of age is, and this is, and we can actually find what is the annual income of different people. So that could be, apparently annual income is between 70 to 80. That's the highest of that's the most occurring from our data. And if so boxplot, I'm pretty sure, yesterday was covered, but I just want to make sure that this will give us mean and median and maximum. So the difference in Python and R is we actually give the predictor dot whatever we want to, let's say box plot or so that's how we give it in Python, but anything in R will just be a function, and in that function we can just give the data. So we can just give a box plot with respect to gender and age. So, or I can just say give me the box plot with respect to, I'm not sure, age will have a lot of okay. So this is just age and age. I think I should do that the other way, but X and Y changing. So if you're considering just the annual income and the age, I'm pretty sure this should not be making sense, but yeah, it should basically, the box plot should basically give the mean, median, and the outliers where we can see, we can consider this as, okay, this is not, it's higher than the maximum, and we can just, we don't have to consider that data point. So this GG pairs is basically giving us all the, so depending on what the age and gender is, or what the correlation is, and between age and the gender, we have this kind of plot. So we can probably, this basically gives us an understanding of if there are any outliers or no outliers, or what the correlation is. So this is the scatter plot. If I say plot of, I want a scatter plot of age with respect to annual income. So we see that as the aging is increasing, probably the annual income is not increasing, but we do see that people between 30 to 40 have higher annual incomes here. So if we're trying to cluster that, we do not know that the data, I mean, I do not know what the trend is. So I'll not be able to give them to a classification model. So we do not know what label we're trying to find, then we actually do the clustering. So I think we're just running out of time. I'll just give you an overview. So here we're scaling the whole data, and male and female as to 1 and 0. So as factor will actually change my male and female. I cannot put male and female into a model because it will not understand how to make the changes part. So I'll say, okay, give a male, consider male as 1 and female as 0 or any numbers, and change them into, okay, give me the data for this. So the box plot will actually give me 1 and 0. Okay, I'll just go back to this. So here it'll basically show, okay, this is probably male and this is probably female, and what is the scale of, what is the age. So we're trying to find out, we're trying to change factor. I mean, we're basically trying to give it 1 as a variable and 0 as a variable. And so what this elbow curve is doing is, we do not know how many clusters or K value, which best K value we should be considering in order to cluster cluster the data. So usually we use the elbow graphs to determine how many clusters are ideal. So the amount where it gets stable is the best clustering metrics. So let's say this elbow graph is just reducing and there's nothing more than 10. So probably I should give like It could probably, I mean, what elbow graph is usually, if whenever it gets saturated, the saturation point would be the best clusters. So we see that there's not much change and after 10, but let's try to check for, if I give k means for n centers, I mean 5 centers. So if I give 5 centers as centroids, and it's basically clustering them into all the data into different groups. So all these observations are sorted into different clusters, and it's basically giving us what are the means, what are the cluster means out of it. And then once we group them, depending on whatever it has given us, we're actually finding, okay, what is the new mean now after grouping them into different clusters, and what is the new mean of annual income. So k-means is basically here trying to sort them, and it is giving new new mean for our sorted data. So this plot basically gives us, depending on data, so if all these are the observations and what all observations are sorted into what clusters. So we can see that probably the least number of clusters are, probably the least number of data points are there in cluster 1. And probably the highest number of data points are there in observations or the data points in cluster 4. So we can also see here that cluster 4 has the maximum coverage, and this has the least coverage. So basically the amount of division is maximum in cluster 4. So if you're considering hierarchical clustering, we can see that what are they clustered into. So here the data is pretty, the numbers are best, but this is basically trying to give on the distance, saying, okay, from the similarities that the algorithm found, all these numbers will be, all these observations can be sorted into one group. So this is basically trying to group them into dendrograms where, okay, these two are one group, and then the other two are one group, and they have another group with the group with something else. So this is how hierarchical clustering will give us, depending on the similarities which the algorithm has found. And so here, grouping by the hierarchical clustering, the age mean is 26, but what did we find in k-means? Yeah, k-means age is saying probably 49, depending on what the algorithm thinks the clusters are. And for age class, we see 26. So how do we actually determine these number of clusters? That is basically done by elbow plot. And we can obviously, there's no optimal solution saying these are the number of clusters to be in, are supposed to be the right number. Or so it's more like a trial and error. So if we get proper clustering, if we get a good elbow graph with a really good cutoff point, we can use that. If we do not get, we actually did not get a proper saturation point for our elbow graph, so it's just increasing. So usually the elbow graphs are more like, they actually have a proper cut and a saturation, so that they can just continue. We can just take the optimal K point as the best K. And okay, I think we're running out of time. And so we're just checking what are the cluster points for from hierarchical clustering we got. And so this is basically showing us probably the maximum points in cluster 1, and there are probably the least points in cluster 4. Right, so the maximum points are in cluster 1 here, and the least are in cluster 4. So we're just trying to plot KNN, but this is more like, so there's one more clustering algorithm that we have used here, that is DBSCAN. So apparently DBSCAN, after grouping it, it says the cluster mean is, I mean, for zero cluster, the mean is 31 and 43. So this is probably saying, that it has maximum data points in first cluster and probably minimum in third cluster. And then all these points from the algorithm that says, okay, given the number of clusters, these are my noise points. So that's pretty much it. And I think that definitely you can try different algorithms and see how clustering works and how decision tree works. But these are the ones which I thought are useful mostly for clustering. And please let me know if there were any questions, and I can just stop staring my screen.
If you guys have any questions, now this is the time to ask from Sneha.
So basically, I think you all got the overview of it, and after dividing the data into several points and grouping them, then we use them to for processing it into machine learning models. Hi, I'm getting hi, Ravneet. Do you guys have any other questions? Sure. So I can give my packages. I mean, sure, I can give the packages to you, and definitely if you need any help, you can email me. There'll be a mail. I mean, I think SSF can send you a mail with my email and slides, and I can send you the code as well. Sure. Sure. Thank you. I guess if you have any other questions, please let me know. Okay. Sure. So I think this was a lot to take, but my slides can give you an overview of what data mining is about and how R can work. So
thank you, Sneha, for your presentation. And
sure.
If you have any question, I'll send you the slides and the recording of the presentation. And I'd include Sneha's email address in that mail, so you can ask the questions if you have any questions. Thanks, Sneha, again, and thanks for all for participating. So tomorrow we are going to have our day 3 and the final day of the programming seminar. It will be about introduction to deep learning with Dr. Timothy Havens. So I encourage you guys to participate tomorrow as well. But tomorrow the time will be different. Tomorrow it will be 2:30 to 3:30. See you tomorrow. If you like to attend the tomorrow's seminar, and have a great night.